Okay, G, we've looked at a lot of sampling distributions now, and they usually seem to be normal. Is that always the case?
That's a really good question. Are they always normal? There's some cases where they're not normal. Let's try to figure this out by doing a bunch of experiments, right? So this is an app where you could actually put in your own population really easily. You could draw it in, or you could choose one of the ones from this little box right here, and we could just see what will the sampling distribution of means look like, right? And so just to orient you, here we've drawn in a normal distribution, and it goes from 0 to 32, but most of them are clustered around 16, the middle, and so the mean of this parent population is 16. That's what we would think of as mu, right? And the standard deviation is shown to you in red. There's one standard deviation above and one standard deviation below. And the standard deviation, or sigma, is 5, right? And so there's, on average, these data points, these squares, are about 5 units away from each other, right? So let's start by just taking one sample, n equals 25. So I'm going to calculate the mean of this sample, but first I'm going to just show you what it looks like to pull a random sample of 25 from this parent population. And notice that many of my data points are clustered in the middle, just like it is clustered in the population. And then we're going to calculate the mean of this sample and drop it out right in here.
Gee, how can you tell that's random? It doesn't really look random.
This application is programmed so that it pulls randomly from this parent population. So now let's take one more random sample and see what it looks like, because will it look exactly like this random sample? Probably not. Let's see. So here's 25 data points being randomly pulled from this parent population, and then we're going to calculate the mean of this and drop it right down. And so notice, this sample looked different, right? It wasn't the same sample that we drew before. But the mean is in a very similar place to the mean that we drew before, right? So now, instead of doing this again and again very slowly 10,000 times, I'm going to click this button here that says 10,000, and it's going to take 10,000 samples of size 25 and immediately drop down their means. And what do you see? Whoa, that looks pretty clustered in the middle, right? And if we're going to draw, we could actually fit a normal curve over it by using this mean and standard deviation here. And look, it's kind of like that model of California idea. This is like the best fitting model for this crazy bunch of means, right? And notice that when we have a sampling distribution, that this distribution can have its own mean. And let's take a look at what this mean is. This would be mu sub y bar, right? And so mu sub y bar is 15.99. Very, very close to the parent population. And the standard deviation is much smaller. And you could see that this parent population is much, much more variable. These data points, these individuals vary a lot more than the means do. The means vary not very much, right? Okay, so fine. For a normal population, sure, I'll give it to you. Maybe the sampling distribution of means will have a normal shape. But what about some of these other distributions, right? Like, what about if the parent population was uniform, right? We've actually done an example like this with the dice rolls, but let's take a look. Let's just take one sample and let's animate that, and then look. So now it's going to take data points from all over here with a pretty equal probability, right? So these data points are from all over the parent population, but the mean is in the middle of all these data points, right? And it's getting dropped out. Let's skip straight to 10,000 samples from this parent population. Whoa, boom, did you see that? It looks pretty good, it looks pretty normal, right? And we could also see that the mean of this thing, 15.96, is pretty close to the mean of the true parent population, right? Hey, so even for uniform, right? But what about skewed, huh? I bet for a skewed, maybe this thing will look skewed. I don't know, right? So let's see. Let's look at a skewed parent population. You can see that it has a long tail over on this side. So most of the data points in this parent population are clustered right down at the bottom end of the scale, right? So let's take one sample. And so here we see that in this sample, a lot of the data points are going to come from this side of the scale, because that's where a lot of the data points are in the population, and the mean is going to drop down there, right? will this mean look roughly normal? Let's see. Let's do 10,000 samples. These are all the means, and what do you see? Oh my God, right? This looks pretty normal, right? You could see that nice normal curve over it, and it looks like it fits right under there, right? And let's check. Look, the mean of this distribution of means, or the sampling distribution, is pretty close to the mean of the population. Well, let's get crazy. It turns out with this, we could actually draw a custom population, right? So we could just change the skewed right here into custom. And we could draw whatever we want. We could draw crazy squiggles, we could draw blocks, we could draw different chunks, right? You could try to write your name, you could do whatever you want up here, right? And so notice, we're gonna draw this kind of crazy looking population, almost like an anti-normal population, right? Now, what about in something like this, right? Is it even possible that we get a normally distributed sampling distribution of means? Is that possible? Well, let's see. Let's do one sample of 25. So it's randomly drawing. And notice that it's just randomly drawing from these two clusters in the population, because that's where the samples come from, right? And notice there's nobody in here. There's no data points in there. Yet the mean of this cluster and this cluster is the middle, right? Because the mean is the middle. Wait, let's take another sample. Let's take another sample just to see if what we're seeing is true. We're seeing data points over here, data points over here, but when we take the mean of this whole sample, what are we gonna see? Boom, it goes down there. Now, what shape will this look like? Will it be clustered around the middle? Let's do 10,000 samples. Oh my goodness, right? Did you expect that? That's amazing, right? So this is really nice. It looks like a perfectly normal distribution from this crazy stuff up here. And you could feel free to play with this simulation. We've given you the link. Feel free to draw some crazy things up in there. Try to get something that's not normal in the distribution of means with a sample of 25. Try to do that. If you find one, let us know.